Hello, I'm Ben Bongalon.
And I'm Joel Ilao.
We're delighted to be part of this virtual conference. And on behalf of our team, Joel and I will present our paper, Using Open Source Tools to Digitize Lexical Resources for Low-Resource Languages. First, we'd like to introduce our team. I'm an independent researcher living in the San Francisco Bay Area. My interests are in Philippine languages and its pre-colonial history. Career-wise, I've been working in technology in the areas of software development, robotics, and machine learning.
I am Joel Ilao. I'm an associate professor from De La Salle University, and I'm based in Manila, Philippines. My research interests are the following: corpus linguistics, as well as DSP, computer vision, and robotics and automation. Our other co-authors are also faculty members from De La Salle University. There's Ethel, who's also an associate professor from the College of Computer Studies, whose research areas are in NLP and conversational interfaces. Rochelle, Irene Lucas, who comes from the Department of English and Applied Linguistics in De La Salle University, whose areas are in psycholinguistics, bilingualism, and language documentation. And finally, we have Melvin Jabar, who is from the Behavioral Sciences Department, who specializes in intercultural family, sociology of education, and indigenous cultures. So let me tell you more about the languages in the Philippines. Philippines is considered to be the most linguistically diverse countries in the world, ranking 25th among countries listed in the Ethnologue. There are 187 languages spoken, 175 of which are indigenous, with a population of more than 100 million. And it is worth noting that only 10 languages are considered major, having at least 1 million speakers as of the 1990 census, with the number of speakers per language tapering exponentially beyond the first 10. In fact, the report by the Summer Institute of Linguistics through the Ethnologue mentions that 13 Philippine languages are already endangered and 11 are actually dying. So the focus of our linguistic study is the tribe that lives in Mindoro, somewhere near the middle of the Philippine archipelago, as you could see here in this red circle. This slide shows the Mangyan members in their traditional clothings. The Mangyan people are comprised of tribes that are referred to as Alangan, Bangon, Buhid, Hanonugo, Iraya, Ratagnon, Tadyawan, and Taubuwid. And the focus of our study, the Hanonugo tribe, inhabits the southern portion of the Mindoro Island, specifically in the towns of Mansalay and San Pedro. It was not clear how the Hanonugo Mangyans settled in Mindoro, but it was believed that they arrived in the area before the Spanish colonization in the 1500s. So they originally occupied the coastal areas but were driven to the hinterlands after Muslim and Christian immigrants invaded their lands. The Hanonugo is one of the languages of the Mangyan population, with 13,000 remaining speakers as of 2000. And unlike other Filipino languages, the Hanonugo Mangyan has an orthography, but few members of the ethnic group can still read and write using this orthographic system. You can see here in the slides is a picture of a bamboo where they write their script, typically in the form of poems. In an effort to document the language of the Mangyan, the De La Salle University embarked on a project which we call as the Hanonugo Mangyan e-Dictionary Project. We conceptualized it last 2016, but it was only given approval last 2018, and we did that for almost 2 years. So this was funded by the government through the Department of Science and Technology and supported by the Department of Education. So in conducting this project, we needed to secure free and prior informed consent through the National Commission on Indigenous Peoples and the Hanonugo Mangyan Council of Elders. In this project, we did the rapid word collection, which was suggested by the Summer Institute of Linguistics, where community members who are considered native speakers served as informants.
So interestingly, an earlier version of the Hanono English Dictionary was already created in 1953 by Harold Conklin. Harold Conklin is an American anthropologist who studied indigenous culture especially the Philippines. He served in the US Army during World War II and was stationed in Luzon in the northern region of the Philippines. After the war, he did field work in the country, including the island of Mindoro where the Hanonugo Mangyans live. There, he studied the Hanonugo Mangyan language and culture, from which he published several manuscripts, including the dictionary. The Conklin Dictionary itself is quite extensive for its time, and it contains roughly 5,800 entries. Even though the Conklin Dictionary is roughly 70 years old, many entries are still relevant and can be used to augment our e-dictionary project. We completed digitizing the Conklin Dictionary last February. The process is known as retro-digitization, which means the conversion into digital format of a work designed and published in an earlier era. The idea has been around for over 25 years. Samuel Johnson's A Dictionary for the English Language, published in CD-ROM in 1996, is perhaps the earliest retro-digitized dictionary. Grimm's 1854 German dictionary was digitized in 2003. And in the last several years, historical dictionaries in Portuguese, Turkish, and other languages have been digitized. But notably, most of these projects are for dominant languages. Our project is one of the few that caters to minority and, in particular, indigenous languages. In a way, this is not surprising because retro-digitization for low-resource languages is especially challenging. Number one, there's few lexical resources available. Often, the languages don't have dictionary and they only have word lists. Second, if physical copies of the dictionary are available, they may be hard to find. And third, it's unlikely that there would be pre-built OCR software that can convert those into text. And then finally, many of these languages have limited funding to do these retro-digitization projects. While we were fortunate to have Conklin's historical dictionary as a resource, we faced the other three challenges. So we developed a retro-digitization workflow that is sensitive to these concerns. We followed the high-level steps defined in the Daria Teach Digital Humanities projects, and the steps are planning image capture, text capture, data modeling and enrichment, and publishing. We made post-edits in steps 3 and 4, and I will now go over the technical steps in the next several slides. Image capture. The purpose of image capture is to convert the physical document into an image file, typically in PDF. Because the dictionary is only available in print form and is rare, we chose non-destructive scanning. In the text capture step, you convert the image document into plain text. This is a busy slide and the details are described in our paper, so I'll just highlight the key steps involved. Because the Hanonugo dictionary contains special characters that can't be recognized by the existing OCR software, we needed one that's trainable. We chose the open source Tesseract engine for this purpose. And to make the training easier, we did what's called fine-tuning instead of training from scratch. To fine-tune Tesseract, you need two things: a pre-trained language model as a starting point and some training data where Tesseract can learn to recognize the special characters. For the base model, we tried Tagalog first, which is since it is a Philippine language, but found that the Spanish language model was better in recognizing vowels with diacritical marks. So we used the Spanish model instead. To create the training data, we used the original Spanish text that came with the model, then mixed in some Hanonugo text selected from 20 sample pages of the Conklin dictionary. We ran a total of 8 training experiments using variations of the training data to find the best performing model. And surprisingly, we only needed 40 lines of Hanonugo text to be added to the original 68 lines of Spanish training data to tune the OCR to achieve 98 to 99% accuracy. Then we used the trained model to transcribe 270 vocabulary pages of the Conklin Dictionary. We hired 2 freelance proofreaders to correct any remaining OCR errors on the page. In the data modeling step, our goal is to mark up the entries with XML tags to encode the dictionary's microstructure. Here's an example entry from the Conklin Dictionary. To convert it, we parse the various lexical entries into separate XML elements. We remove the special characters from the head word to make it easier to search, and then we added another pronounce field. We used the TEIO dictionary encoding standard for the markup, and we wrote a Python program that uses pattern rules to perform the conversions that I just described. In the post-edit step, we used the open source Lexonomy tool to enhance our dictionary. And to make editing easier, we temporarily added extra markup in the XML page to preserve the page structure. We call this page view mode. And by doing so, we can quickly compare each digitized page against the original PDF source. The last step is publishing. We use the Lexonomy software to host the e-dictionary. And because we wanted to customize the software, we hosted it on our own server. There were 3 things we needed to do to load the dictionary into Lexonomy. Number 1, from the configure menu, we defined the dictionary schema as shown on the right. Then we uploaded the XML entries. And then on the 3rd step, we styled the page layout and colors using XSL and CSS. The Conklin Dictionary is available for research purposes, and access is granted on an individual basis in consultation with representatives of the Mangyan community. Although digitizing the Conklin's Hanonugo language was an extremely rewarding project, we encountered some challenges. First, while Tesseract is a powerful OCR software, training it is still an art. For example, finding the proper training data is a process of trial and error. Also, we learned that you may have to repeat the training multiple times to get the best model. This is because Tesseract randomizes the input data, which produce small variations in the final model accuracy. Second, transforming the OCR text into XML requires someone in your team who can program, and this may be a barrier for some projects. Third, Lexonomy does not limit user access to a subset of the dictionary, and proofreaders, as a result, may override each other's work. As a workaround, we split the dictionary into batches and assign them to each editor. And then finally, we observe a lack of data interoperability among the lexicography tools. For example, one must write a custom program to import Lexonomy entries into SIL's mobile dictionary app builder. In closing, we developed a low-cost workflow using open source tools for digitizing historical dictionaries, and we've successfully used it on the Hanonugo language dictionary. We hope this will lower the bar to retro digitization and encourage more e-dictionaries to be made for other languages and give minority and indigenous communities an easier way to create digital resources. A tutorial is available in the link below, so please try it out.
So we believe that the workflow that we just described is a viable model for language documentation efforts that have limited funding but have readily available resources. However, there are also issues that future researchers would need to contend with, as listed in this slide. First and foremost is to ensure getting the consent of the language community before you write the proposal. Otherwise, efforts will be naught if the community doesn't want their languages to be digitized. We also need to allot enough time in securing free and prior informed consent. In our experience, we had to wait for almost 2 years to complete the whole process, which entailed several consultations with the community and working with the government. A second issue is the lack of available lexical materials, which requires prior huge efforts in building relationships with institutions and organizations that can provide them. Thirdly, there's the issue of combining digital linguistic data from different resources, having different formats, and levels of organizations, and converting them into a format that can be fed into the e-dictionary system. Finally, we would need a more robust data management to maintain and grow e-dictionaries, considering both speed of collection and the quality of data, in adopting new collection techniques such as crowdsourcing. So thank you very much for your attentive listening. And together with Ben and our other co-authors, we are looking forward to your feedback and entertaining your questions in this forum.
Thank you very much, everyone.